Between negative pi on 2 and pi on 2, remember that we're always going around this way. So negative pi on 2 to pi on 2 would be this region here. Okay, so what we're going to have to do is actually pick this one. This is 5 pi on 3. That's going to be the one here. But we also have to express it in a way that puts it in this region between negative pi on 2 and pi on 2. So to do that, we just have to re-express this as a negative angle, and it's going to be negative pi on 3 because we're going back pi on 3 this way. So our answer, so for A, inverse sine of negative root 3 over 2 equals negative pi on 3. That's the only angle there that's going to be in our appropriate range. Okay. For the next one's for B, the thing that I want you to look at here is you've got an inverse sine and a sine. Okay. Now, because one is the inverse of the other, they effectively cancel each other out. All right. So all you really need, it's sort of like timesing and dividing. Okay. If you times by 5 and then divide by 5, well, you're back to where you started. So we can do the same thing here. We can effectively cancel out. All we have to do is to make sure that our answer, our angle answer that we're getting here, is in the correct range again. Okay, so for the first one, for I, this is a nice one. We've got inverse sine, and it's sine of pi on 6. Okay, now because you've got the two angles here, the sine and the inverse sine, one is the inverse of the other, they cancel out, and we just end up with pi on 6. And just check that this is in the right region here. Pi on 6, in terms of the unit circle, is over here. Sometimes you might have to pick another answer that's the same sign but just in a different region. But pi on 6 is in the correct region for us, so that is our answer. If you wanted to do this another way, the other way of doing this is a longer way, is sine of pi on 6, which we know pi on 6 is here, sine of pi on 6 is a half. Then what you're doing is you're asking, okay, sine of what angle would give you a half? That's what this question asks you. Sine x equals a half. What does x equal? And we know that x is going to be pi on 6. So it gets us back to here. So you can do these questions by actually doing what's in the bracket first, which is here a half, and then figuring out the inverse, or because you know that they're both opposites of each other that they can cancel. So the next one, 2, we've got inverse sine of 5 pi on 6. Now this is one of those ones where you have to be careful because 5 pi on 6 in terms of the unit circle is over here. So for that sine value, we can actually use the equivalent on this side, which would be pi on 6. So we can rewrite this as inverse sine of pi on 6. And we know from the question that we just did, the inverse and itself cancel out, so we end up with pi on 6. It's a nice easy one. The third one, inverse sine, and now we've got cos. Now again, there's two ways you can do this. I'll show you the quicker way first. So we can do inverse sine. Now cos of pi on 3, thinking about the triangle here, cos of pi on 3 is saying this angle over this angle. So we know that we're talking about this here, a half. Okay. Now the other way you could express a half is to talk about, rather than cos of pi on 3, a half would be the same as sine of pi on 6, yeah? Because it's always the opposite angle. Whatever the angle is here with the standard triangle, it's the opposite. Cos of pi on 3 is the same as sine of pi on 6. So now that you've actually got an inverse sine and sine, it nicely cancels out and you end up with pi on 6. They don't always end up with an answer of pi on 6, by the way. It just happens to be how it's going here. So you can do it that way. That's nice and quick. Or the other way that you can do it, if you want to, is to actually figure out what cos of pi on 3 is, which you know is a half. And then this is actually saying to you, sine of x equals a half. What does x equal? And we know that that would be pi on 6. Okay, so either way you're going to get the answer of pi on 6. For the last one, I'll just do this one here. We're looking at an inverse sine, inverse cosine. So again, with this one, we're actually interested in a different triangle. So this is the 45 degree or pi on 4 triangle. And you know that with that triangle, because it's got the same sides there, root 2 on 2 and 1, we know that sine of pi on 4 is the same as cosine of pi on 4. They're actually the same value. So you can rewrite this as sine of inverse sine, okay, of root 2 on 2, because in the 45-degree triangle they're interchangeable. And again, you've got trig and its inverse. So this time you'll actually get an answer which isn't an angle, but which is a number. Okay. The other way that you could do this, if you want to do it the long way, and I'll just get rid of this section, is to do it in parts. So we've got sine of inverse cosine, root 2 on 2. This part here says to you cos of what angle gives you root 2 on 2, and we know that that angle would have to be pi on 4. So what we have then is sine of pi on 4. What you've done is you've replaced all of this region in here with pi on 4, okay, to get your answer. And we know that sine of pi on 4 is root 2 on 2. So either way that you do it, either with cancelling out the inverse and the original, so sine and inverse sine, or by going through and doing the bracket first and then working out. Remember, with these, always work out from the bracket, okay? Either way, you're going to end up with the same answer.